Welcome. I am Velumani, Assistant Professor in the Department of Civil Engineering, Kamaraj College of Engineering and Technology. In this lecture, we are going to see centroid and center of gravity. So, centroid is nothing but the geometric center of the figure. You can see the different figures are given here, where the capital G denotes the centroid of the image, whereas center of gravity is a point where the entire weight of the body acts, but in the centroid the point where center point of the object lies. So, there is a difference between these two, centroid and center of gravity. It is an important parameter to find the moment of inertia, polar moment of inertia. In this lecture, we are going to find a different shapes center of gravity by solving different problems. Let me take an object. This is a writing pad. To balance this writing pad in a single point, I need to place my finger on the exact center of gravity point. If I place my finger anywhere other than the center of gravity, the pad will not be stable or it will topple. So, we need to place exact center of gravity point. We need to identify first, then we can place the pad like this, so that it can be it cannot be toppled and it can be balanced and it will be in equilibrium state. So, this kind of center of gravity can be found out by using different formulas. Now, I am going to work out on problem. Let me take an example, a symmetrical I section. A symmetrical I section of size 100 mm by 100 mm. And the flange depth is 10 mm, web thickness also 10 mm. Now, I am going to find out the center of gravity of this I section. Before going to find the center of gravity, we need to draw the reference axis x and y axis. So, we need to draw the reference axis at the bottom x and left it is a reference axis y. With reference to these two reference axes, we can find the center of gravity of the whole figure. So, since it has three portions, we need to divide into three smaller parts, smaller rectangles, so that by knowing the center of gravity of three parts, we can find the total center of gravity. Let me take this portion as a first one, and the second web portion as second portion, and the top flange as a third portion. Now, I am going to find out the center of gravity of each portion, and by substituting the values in the formula, we can find the total center of gravity. So, the center of gravity can be found out by the formula x bar, that is center of gravity about x axis is a1 x1 plus a2 x2 plus a3 x3 whole divided by a1 plus a2 plus a3, where a1, a2, a3 are the area of each portions, and x1, x2, x3 are the center of gravity about x axis of each portions. Likewise, we can find the center of gravity about y axis, that is y bar, by using the formula a1 y1 plus a2 y2 plus a3 y3 whole divided by a1 plus a2 plus a3, where a1, a2, a3 are the area of each portions that we already know, and y1, y2, y3 are the center of gravity of each portions, each smaller portions about y axis. So, we need to find all these parameters first, then we can substitute all these values, we can find the center of gravity about x and y axis. Now, I am going to find out the center of gravity of each portions about x and y axis first. For that, let me consider each portions separately. So, this is the first portion and this one second one and this is third portion, and the dimensions of the figure is 100 mm by 100 mm and the flange depth is 10 mm and the web thickness also 10 mm. Now, I am going to find out the center of gravity about x axis first. So, let me take x1 as center of gravity of first portion about x axis. So, it is nothing but the center point of the first portion, means the half of the width of the bottom flange, that is 100 by 2, it will be around 50 mm. So, x1 is 50 mm. Likewise, we need to find the y1 value, that is center of gravity about y axis also with respect to the bottom axis, bottom reference axis x. So, this will be 5 mm, that is half of 10 mm. So, y1 will be 5 mm. Now, I am going to calculate the area of the first portion. So, area of first portion can be represented as A1 and the dimension we know 100 mm by 10 mm. By multiplying these two, we will get 1000 millimeter squared as A1. Now, I am going to find out the center of gravity of second portions and also the area of second portions now. So, the center of gravity of second portion about x axis can be denoted as x2. So, this will be from center to the reference axis y. So, it will be same like 50 mm like first portion. So, x2 is 50 mm and now I am going to find the y2, which means the center of gravity of second portion about y axis from the reference axis x. So, this will be half of the entire depth of the section. So, the total depth of the section is 100 mm, which is given in the figure itself. So, the y2 value will be 50 mm. Now, I am going to calculate the area of the second portions. The second portion dimension is 80 mm by 10 mm. So, by multiplying 80 mm and 10 mm, we can get the area of the second portion, that is 800 millimeter square. So, we have calculated the center of gravity and the area for the first and second portions. Now, I am going to find out the area and the center of gravity for third portions. So, let me take x3 as center of gravity of third portion about x axis. So, it will be lies here from the reference axis y, the x3 value can be calculated. The x3 value will be 100 divided by 2, that is the exact half amount after the value. So, x3 is 50 mm. Now, I am going to find out the value y3, that is center of gravity of third portion about y axis. To subtract 5 mm from the 100 mm, we will get 95 mm as y3 value. And again, I am going to find out the area of the third portion. Area of the third portion will be 100 by 10 mm. The dimensions of the third portion is 100 cross 10. So, the A3 will be 1000 millimeters square. So, by knowing all these three values, we can find the center of gravity about x and y axis for the whole figure. Now, I am going to substitute all these values in the formula. We know the center of gravity of about x axis formula is A1 x1 plus A2 x2 plus A3 x3 whole divided by A1 plus A2 plus A3. The first portion, area of first portion is 1000. So, let me substitute the A1 value as 1000 and x1 value. The x1 value is 50 mm. So, substituting x1 as 50 plus A2, that is area of second portion is 800, area of second portion is 800, and the x2 value for the second portion, that is center of gravity about x axis for the second portion is 50 mm. I am substituting x2 as 50 plus A3, that is area of the third portion is also 1000 millimeter square. So, I am substituting A3 as 1000 here into x3 value, that is center of gravity of third portion about x axis, x3 is 50 mm. So, let me substitute x3 as 50 mm here, whole divided by A1 plus A2 plus A3, that is area of first portion 1000 plus area of second portion 800 plus area of third portion, that is also 1000 mm square. So, by calculating this, we will get the exact x bar value, that is center of gravity about x axis for the entire figure. The answer will be 50 mm. Likewise, we need to find the y bar value, that is center of gravity of about y axis for the entire figure. For this, the formula to find the center of gravity of y bar will be A1 y1 plus A2 y2 plus A3 y3 whole divided by A1 plus A2 plus A3. So, formula is A1 y1 plus A2 y2 plus A3 y3 whole divided by A1 plus A2 plus A3. We know where A1, A2, A3 are the area of three different portions and y1, y2, y3 are the center of gravity about y axis for all three portions. So, I am going to substitute all these values first. So, we know first portion area is 1000 mm square. Let me substitute A1 as 1000 and y1 value. The y1 means the center of gravity of first portion about y axis, that is 5 mm. So, I am substituting y1 as 5 here plus A2, that is area of the second portion is 800 mm square. So, substituting A2 as 800 and y2 value, that is center of gravity about y axis for the second portion, that is 50 mm. So, I am substituting 50 for y plus A3, that is area of the third portion, that is also 1000 millimeter square. So, substituting A3 as 1000 and y3 value. Y3 is nothing but the center of gravity of third portion about y axis, that is 95 mm, that we have already calculated, and whole divided by A1 plus A2 plus A3, that is area of first portion 1000 millimeter square plus area of second portion 800 mm square plus area of third portion 1000 millimeter square. So, by solving this, we will get the center of gravity value as 50 mm, because this I section is a symmetrical about both x and y axis, symmetrical about both x and y axis. So, the center of gravity for this I section lies exactly at center point of the I section. That is why this 50 mm is x bar and this 50 mm will be the y bar. So, that the center of gravity of symmetrical section can be find out easily by just by dividing the size of the section. Likewise, we can find out the center of gravity of irregular shapes also. Thank you.